Good afternoon, all of you. Today I am going to deliver lecture on application of phosphorus ylide. We know that phosphorus ylide are also called as Wittig reagent. Okay, phosphorus ylide are also called as Wittig reagent. So, phosphorus ylide are also used in Wittig reaction. So, the first application of phosphorus ylide is Wittig reaction. So in the Wittig reaction, we will see introduction of Wittig reaction, statement of Wittig reaction, the reagent and solvent are used in the Wittig reaction, and the mechanism of the Wittig reaction. These are all the contents of Wittig reaction. We will see one by one. Firstly, introduction. Wittig reaction firstly introduced by George Wittig in 1954, for which he was awarded Nobel Prize near about in 1979. Okay, Wittig reaction is firstly discovered by George Wittig in 1954, for which he was awarded Nobel Prize in 1979. Wittig reaction generally are used for the preparation of alkene. So this is the introduction of Wittig reaction. Now the second content of the reaction is statement. Statement of the reaction are very important aspects. Because of we will understand the statement, we will easily understand the reaction. Listen. The reaction in which aldehyde or ketone, the reaction in which aldehyde or ketone react with ylide generated from phosphonium salt gives alkene and triphenylphosphine oxide called as Wittig reaction. The reaction in which aldehyde or ketone react with ylide generated from phosphonium salt gives alkene and triphenylphosphine oxide called as Wittig reaction. The reaction in which aldehyde or ketone react with ylide, which are generated from phosphonium salt, use alkene and triphenyl phosphine oxide called as Wittig reaction. So this is the statement of Wittig reaction. Now the third content of the Wittig reaction is solvent and reagent that are used in Wittig reaction. So basically in Wittig reaction, triphenyl phosphine alkyl halide and butyl lithium and any aldehyde are used as a reagent. And THF and DMSO are used as a solvent. So these are the reagent and solvent that are used in the Wittig reagent. Triphenyl phosphine, alkyl halide and butyl lithium and any aldehyde is used as a reagent in Wittig reaction, and also THF and DMSO are used as a solvent. Now the third content of the Wittig reaction is the solvent and reagent are used in the Wittig reaction. Now the fourth content of the reaction is mechanism. So we will see it. Mechanism. Now I am written here the general representation of Wittig reaction. These are the aldehyde. I am written here in this type. So this is our phosphorus ylide, okay, and we will get alkene and triphenyl phosphine oxide as a product. So how to get alkene? Now look here. This is the alkene and pH 3 So now I am going to discuss the mechanism of Wittig reaction. The mechanism of Wittig reaction are initiated from the formation of phosphonium salt. We can listen the Wittig reaction means the reaction of aldehyde and ketone the reaction of aldehyde and ketone with ylide, which are generated from phosphonium salt. So initially we will form in the mechanism of Wittig reaction phosphonium salt that are converted into phosphonium ylide, and that are used to preparation of alkene in Wittig reaction. So firstly the reaction mechanism is initiated from the preparation of phosphonium salt. We know that the phosphonium salt will be prepared by the attack of triphenylphosphine with alkyl halide. Let's see here. This is the triphenylphosphine is reacted with this alkyl halide. We know that this reaction undergoes asymptotype. So what will happen here? The lone pair of phosphorus attack on this carbon atom. Simultaneously, bromine will be detached from this carbon atom, and we will get phosphonium salt as an intermediate. PPH3 positive, CH2, CH2, CH3, Br. So this is the phosphonium salt. Okay. So in the reaction mechanism of Wittig reaction, firstly we will prepare phosphonium salt by the reaction of triphenylphosphine and alkyl halide. This reaction is undergoes like SN2 type. Now the form phosphonium salt converted into ylide by the use of strong base. So here I am use N-butyl lithium as a strong base. So this is the N-butyl lithium and used here as a strong base. We know that strong base extract the one proton from that carbon atom and converted phosphonium salt into phosphorus ylide. PH3P positive, single bond CH negative, CH2, CH3. This is the phosphorus ylide. And here also N-butane will be formed with LiBr. Okay. After the formation of phosphorus ylide, this phosphorus ylide is interact with aldehyde. Aldehyde are the fourth reagent of the Wittig reaction. I am written here firstly newly formed phosphorus ylide is the uniform phosphorus ylide that react with aldehyde. Suppose I am here taken this type of aldehyde. So what will happen here? Here the phosphorus ylide is added over the CO group of carbonyl compound, like a conjugated addition, and we will get firstly oxophosphotiene intermediate. So before the formation of oxophosphotiene intermediate, the initially unstable intermediate here formed, namely called as butane intermediate. Okay, now listen. What will happen here? The negatively charged carbon of the phosphorus ylide is attacked on this carbon of the carbonyl compound. Okay, due to which the bond between carbon and oxygen shifted toward oxygen. Okay, and we will get first unstable intermediate like that CH. Okay, P positive, pH3, CH2, CH3. Okay, this negatively charged carbon of the phosphorus ylide bonded with this carbon atom and written here this carbon atom, and the carbon have one hydrogen, one ethyl group, and the one oxygen. Okay, and the bond between carbon and oxygen shifted toward the oxygen, so oxygen become negative species. Okay, so this intermediate called as butane intermediate. Okay, this is less stable intermediate, and it is immediately converted into closed ring structure called as oxophosphotiene intermediate. What will happen here? This negative charge of oxygen shifted toward the phosphorus and to form this type of intermediate O. This carbon atom here, this carbon atom here, this carbon atom, it have CH2, CH3 group. Okay, and also the carbon atom have one hydrogen and here one ethyl group. So this intermediate is called as oxophosphotiene intermediate. Okay, this is stable intermediate as compared to butane intermediate. Okay, now the after formation of oxophosphotiene intermediate, this intermediate undergoes a ring cleavage. A ring cleavage. Okay, how to undergo ring cleavage? Now look the structure of oxophosphotiene intermediate. Okay, we know that this is carbon, this is hydrogen. Okay, the oxygen have more electronegativity than the carbon, so it have partially negative charge, and this carbon have partially positive charge. On other side, this carbon have more electronegativity than the phosphorus, so it bear partially negative charge, and the phosphorus bear partially positive charge. So this oxophosphotiene lastly undergoes ring cleavage. So what will happen here? The bond between phosphorus and carbon shifted toward the carbon, and the bond between presents from carbon and oxygen shifted toward the oxygen, and we will get our final product like that. Look here, this is the carbon. Okay, this carbon, this is the another carbon. Okay, it have one C2 CH2 CH3 group, and it have hydrogen. This carbon have one hydrogen and one C2 CH3 group, CH2 CH3 group. Okay, and this bond shifted toward the carbon carbon. So here the one pi bond will be generated, and when we see, this is our final product, alkene. And another product is PPH3, and this was shifted toward the in between oxygen phosphorus. So here another carbon will be generated, and this is another product is called as triphenyl phosphate oxide, and this is our alkene. Okay. So the mechanism of Wittig reaction is initiated by the formation of phosphonium salt. We know that the phosphonium salt are formed by the reaction of triphenyl phosphine and alkyl halide. This reaction undergoes SN2 so it forms phosphonium salt intermediate. This phosphonium salt intermediate immediately converted into phosphorus ylide with the help of strong base and butyl lithium. The newly formed phosphorus ylide further react with any aldehyde. So I have taken this type of aldehyde. Okay, and this is our newly formed phosphorus ylide. Okay, so what will be happen here? The phosphorus ylide is added for the CO group of carbonyl compound. These addition are generally occurs cycloaddition. Okay, initially we will form the bitter intermediate. Okay, what will happen here? This negatively charged carbon of the phosphorus ylide is added for this carbon atom of the carbonyl group. Simultaneously, the bond between carbon and oxygen shifted toward the oxygen, and oxygen become negative species. So this type of intermediate will be formed here. It is called as a bitter intermediate. This bitter intermediate is less stable, so it is immediately converted into oxophosphatane intermediate. As compared to bitter intermediate, the oxophosphatane intermediate is stable. And finally, this oxophosphatane intermediate undergoes ring cleavage. So this type of ring cleavage will be occur here, and we will get our final product alkene and triphenyl phosphine oxide. So the final product of Wittig reaction is alkene and triphenyl phosphine. So this is all about the introduction, statement, mechanism and reaction of the Wittig reaction. I hope you will be understand better. Now the last content of the Wittig reaction is stereochemistry. Now last content the stereochemistry of Wittig reaction is discussed under the Z configuration and E configuration. Means Z isomer or E isomer. Okay. The stereochemistry of Wittig reaction is totally depends upon the reactivity of phosphorus ylide. Okay. We know that in the Wittig reaction, phosphorus ylide used as a reagent. Okay. So the stability, so the stereochemistry of the Wittig reaction is depends upon the reactivity of phosphorus ylide. We know that there are two types of phosphorus ylide. Stabilized phosphorus ylide and second unstabilized phosphorus ylide. There are two types of phosphorus ylide. First one is stabilized, second one is unstabilized phosphorus ylide. We know that the stabilized phosphorus ylide is stable but less reactive. Stable but less reactive. And the unstabilized phosphorus ylide is least stable but more reactive. But more reactive. So the Wittig reaction, the stereochemistry of Wittig reaction is depends upon the reactivity of phosphorus ylide. Suppose in the reaction stabilized phosphorus ylide will be used, then the product alkene will be obtained as a E alkene. The product will be obtained as a E alkene or E isomer. And if in the preparation of Wittig reaction, in the preparation of alkene, the unstabilized phosphorus is used in a Wittig reaction, then the alkene will be formed into Z type isomer. Okay. Here the E isomer is predominant when stabilized phosphorus ylide is used in Wittig reaction, and here the Z alkene is predominant when the unstabilized phosphorus ylide is used in Wittig reaction. So on the basis of reactivity of phosphorus ylide, stereochemistry of Wittig reaction are mentioned. Okay. So this is the stereochemistry of Wittig reaction. I hope you will be understand. Here I am taken 3 examples of Wittig reaction. The Wittig reaction is very important due to the point of CSR net and set. Lot of questions will be asked in CSR net and set on the topic of Wittig reaction. So this is the 3 examples of Wittig reaction. So in the first examples, here I am taken benzaldehyde, okay, and here another reactant is stabilized phosphorus ylide. We know that this phosphorus ylide is stabilized because of here CHO group is attached and it is electron withdrawing group. Okay, so the product will be obtained here is ylide because of the stabilized product is less reactive, hence it gives E types of alkene. Okay, so the product will be obtained here PH single bond H double bond C, here I am written H and here CHO group. So this is our product and it is E alkene. Okay, and also we get PH3 P double bond O triphenyl phosphine oxide. Okay, so in the first reaction aldehyde is treated with phosphorus ylide. Here phosphorus ylide is stabilized, so we will get alkene, and the configuration of alkene is E because of we can use here stabilized phosphorus ylide. Okay, and it is our another product triphenyl phosphine oxide. Okay, now let's see the second example. In the second example, here I am taken this type of aldehyde, and the another intermediate reactant is stabilized phosphorus ylide. It is also stabilized phosphorus ylide because of here OAT group is present. This group is electron withdrawing group. So this ylide is stabilized ylide, and we know that when stabilized ylide is used in Wittig reaction, then the alkene will be obtained ylide. Okay, so what type of alkene here obtained? Ylide, like that H double bond C H O T. So this is E alkene. The configuration of alkene is E, means trans alkene. And another product will be obtained triphenyl phosphine oxide. Okay, so in the second reaction we will see aldehyde is reacted with stabilized phosphorus ylide, then we will get trans alkene or E alkene and also triphenyl phosphine oxide. Now in the third reaction we will get this type of aldehyde, but here I am also gives unstabilized phosphorus ylide. So we know that when in Wittig reaction use unstabilized phosphorus ylide, then the product will obtain Z configuration. So here the alkene will be obtained with the Z configuration, and the structure of the alkene is like that H double bond C H So this is the Z alkene. It is also C alkene. It is also called as C alkene. And the another product will be obtained here, triphenyl phosphine oxide. So these are the different type of example of Wittig reaction, and the mechanism of the all reaction is same. In the first step, phosphorus, phosphorium solid will be formed, that is converted into phosphorus ylide. Then the form phosphorus ylide is reacted with aldehyde and to form a alkene. So this is the three questions of Wittig reaction.